We are looking at Chapter 7, Lesson 4, which is solving logarithmic equations and inequalities. So for this first one, you have a logarithmic equation. The biggest part of this is knowing that if it is in log form, that you need to change it to exponential form. When I do that, I'm literally getting rid of the word log. So log form is currently what you have in this question. So I have log, a subscript, a value is equal to another value. So to change that to exponential, your things really just get rearranged. So your base that's with the log is becoming your base of an exponent. The c is becoming your actual exponent. And then the a value is what it's equal to. So you're rearranging and then dropping the word log. So in this first example, you are first changing it to exponential form. So what that would look like is your 8 becomes your base of your exponent. The 4/3 becomes your exponent, and then it's equal to x. So from here, you are solving. You should be able to plug that into your calculator the way that it is. If it does not let you, the other way that you can also do this is if I have an 8, I can break that down to a smaller base. So thinking about like 2. 2, I can multiply by itself 3 times to get 8. So I can change just the 8 part to 2 to the third power. The reason I would do that is your power to a power rule states that you would multiply your exponents. So whenever I do that, 4/3 times 3, your 3's would cross cancel, so I'm really just left with 2 to the 4th power is equal to x. Again, you can use a calculator, or you're really just doing 2 times 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So your answer to this first question would be that x is equal to 16. So you're solving for x. Moving to example 2. So example 2 is solving something a little bit more complicated. So you have log 4 x squared is equal to log 4, and then in parentheses negative 6x minus 8. For this question, because there's a log 4 on both sides, and the reason this works is if I have log 4 in parentheses, that's really multiplication. So if I were to divide it over from this side to this side, my log 4's would just cancel out. So as long as you have the same log on both sides, they're going to be able to cancel each other out. So whenever I do that, I'm left with x squared equals negative 6x minus 8. For this question, you notice you have an x squared and an x and a number. That should tell you that you are going to have to factor in order to actually solve this. So if I'm factoring, I want this set equal to 0. When I set it equal to 0, I know it looks easier to subtract your x squared over, so you only have to move one thing over. However, I want my x squared to be positive, so I'm actually going to end up adding my 6x to the other side and then adding my 8 to the other side, since I need it set equal to 0 to actually factor and solve. So I would then end up with x squared plus 6x plus 8 is equal to 0. So since I don't have a number in front of my x squared, this is one that I'm factoring by looking at my c value or my 8. I'm finding factors of 8 that are going to add to give me my b value or give me 6. So factors of 8 that would give me 6 would be 4 and 2. So whenever I factor this out, I would write it as x plus 2 and x plus 4 is equal to 0. Then to solve both of those, I'm going to set both equal to 0 and then solve for x. So whenever I do that, I'm going to end up with x is equal to negative 4 and x is equal to negative 2. So I know these are all A's. However, it would really be C is your answer choice. Then looking at example 3. Example 3 is really example 1. And then when we scroll down and look at example 4 in a minute, example 4 is really going to be example 2. The only thing that changed is there's an inequality included in these. It really doesn't change a whole lot. You're still going about the same process. So this is currently in log form, and I'm going to change it to exponential form. So what that looks like is my 6 is becoming my base, my 3 is becoming my exponent, and then I wrote that backwards, so sorry. So my x is actually staying where it is. My 6 is becoming my base on the other side, and then my 3 would move up. So it does matter how you do that, only because of the inequality symbol in your problem. So then I would do 6 to the third power to get my answer, which is really doing 6 times 6 times 6, which would give you 216. So similar to example 1, a little bit easier because it's not actually a fraction. So make sure whenever you are setting these up that your x stays where it is, your base of your 6 is moving to the other side, especially with the inequality ones. If you had done it the other way, you would have had to flip your inequality symbol around. So you could have technically also done this. It would give you the same answer. If you're going to do that, you just need to remember to move or to flip your inequality symbol. Then looking at example 4, example 4 again is very similar to example 2. So there's a log 7 on both sides. So because there was a log 7 on both sides, I can really just cancel them out and really work with the problem that I'm left with. So I would have 2x plus 8 is greater than x plus 5. Up to you how you go about solving. I tend to keep my variable on the left side whenever I'm doing inequalities. So I would subtract this x over first. So 2x minus x is going to give me just x. Then to get x completely by itself, I'm going to subtract 8. So 5 minus 8 is going to give me negative 3. So I would end up with x is greater than negative 3. So again, the only time this works with example 2 and example 4 is whenever you have a log that is the same. So like if you had a log 4 on one side and a log 7 on the other side, because they are not the same, I can't actually cancel them out. Y'all will not see that this year in Algebra 2. This will be something that you will continue working on in Algebra 3 or Trig next year, whichever next step you end up taking. So that is it for Chapter 7, Lesson 4, and that is the last lesson that you actually have in Chapter 7. So